So once again I cleared everything and started from the beginning here. So we have this very white lantern. And in this session I will go through the pointiness, and I think many of you have already used it, and some of you already will think like, okay, but why should we use pointiness when we have things like ambient occlusion and vertex paint and so on? Well, I will show you the difference. So we start right away by selecting the base here and create a new material, pressing new here, and add an geometry. So Shift A, input, and here you will find a geometry node. And in here you have pointiness. And I think in most tutorials you add like a color ramp, so press Shift A, converter, and a color ramp, and somewhere in the middle around here we then get the result if we connect the color with the base color here. So you can see all these lines here. And I don't see so much of a difference here compared to using like only local on the ambient occlusion. But we have some differences. But before I go through them, I think we can copy this material to everything else because it's easier to see. So I go up here to the color material, select everything except the first one, and then Control and Control L materials. And now we have copied everything to the other stuff here. And you can see it's almost the same thing. However, if we now think of another situation, namely, where do we often touch this lantern? Where are the surfaces where we can reach the lantern the most easy way? Well, then it's on the top here. It's where all these edges are like on the top here, where it's outside of the other surfaces. So we have this surface, and if you go here with your hand, the first part that you will reach is this part here. And the same, of course, here. And then it will not be inside here, but it will be outside of all these edges. So if we just reverse this by using the white here and the black here, then you can see what we get. We get all those places where we easily reaches the lantern. So the outside edges, the edges that we are easily reachable, those we get by putting the white here and the black here. So we have like a reversed function that is really, really good to find all those awareness, all those where that we get on the edges. And that you don't get from the ambient occlusion, or if you use the vertex paint in the same way. So here it's really good to use the pointiness. The drawback by using color ramp is, as I said before, you can't use it inside or from an outside if you have it in a node group. So it's another way to do it, and you can add like 3 math nodes to do about the same thing. So I can press Shift A, converter, and the math, and put that in here, and I will use 3 of those. So Shift D to copy, Shift D to copy, and then I take away the color ramp here. And what I will do is change the first one to subtract, the one in the middle to multiply, and the one in the end here to add. And when I change this multiply in the middle, you can see that if I have now a positive value, I get it exactly the same as I get with the other function. But if I use a negative value, then I get all those places where we easily reach the lantern, where it will take away the color because we have touched it so many times. So by using a negative value here, we can then control how much we would like this where to be, if it's just a little bit or if it's much here. And you can see if we take it really high up, then we also take the bigger angles here, so to say. Pointiness has the drawback, same as the vertex paint, that you really need to work with a high amount of polygons. And if the faces of the polygon is really close to each other, then it's highly effective to use the pointiness, because how it works is that it calculates the difference between one face and the neighbor faces. So if you have a lot of faces close to each other, then you get an approximation on a very small area. But if you have like a cube, then you have only one vertex up here, and you have one down here, and then you have like 90 degrees difference on each side, and that's all. And then you don't get any soft translation between them, and nothing happens. So you need a lot of small faces with small variation or differences on the angles to make pointiness work in a good way. And here in a lantern it's a fabulous way, because here we have all these small lines going here, and it's really effective to use this pointiness to get all these places where it could be where. So now we have a tool for that as well. So now we have an easy way to find out, okay, where do we touch this lantern? And then we get this by using the pointiness, but using a negative number here, or if you use the color ramp, then go from white to black instead of going from black to white. So then you get all these places, and that's good. So now we have that as well. So we have the wind, weather, sun, rain, dust, and everything like that. Really good. Now we're almost complete. Do we really need more? Well, perhaps we don't need more, but we have more tools as well. And I think I can take one other thing here, so I don't divide this into two sessions. And the other thing we can use is something called normal. So I think most of you know that the direction here, when we have like a line that goes like directly out from this face here, like 90 degrees, then that is called the normal. And then we have, of course, different directions for each face. So this is pointing that way, and this is pointing that way, and that is pointing like that way, and so on. So those we can use to mask out like everything that is at the top, for instance, and that is good to work with when it comes to dust. So we have dirt before that we collect on all these places using the vertex paint. But if you think of dust like a very light material that will perhaps move a little when you move the lantern, and then it will settle down again, it's more movable than the dirt that is more stuck to the lantern. And that dust, we can say, will easily be on all the things that is going in the direction from, like, if you say that the dust is falling down very, very slow, then this part here and that part here will then catch it. And since it's so light and so small, it will also like go in here and then rotate a bit, and then it will go here as well. So even if we have that lid here or that shelter, it will still collect some dust here. Not as much as up here, but some. So we can use the normal output to get information where the dust will be collected as well. So we can use the geometry here, or we can use the other texture coordinate. So I can press Shift A, input, and texture coordinate like that, and then you can see we have normal here as well as we have normal here. Okay, so I now disconnect the pointiness, and we have learned about that, and now you know that it's a good way to find all those places we easily touch. So we leave that and we go to texture coordinate and a normal. So to use one direction, we need to separate the direction, and this is a blue output, meaning that we have many values, and in this case we have 3 values, 1 for each direction. So I use a separate node here, so pressing Shift A, converter and separate X, Y, Z, and put that into the normal here. And we can use the Z axis to put it in here. You can see directly it's like it's been snowing. So everything that is pointing up, it's white, and then it slowly goes into black when it's pointing in another direction. So we see here you get a soft line here and so on. And that is a good addition to the vertex paint, for instance. So by combining this and the vertex paint, you can then create something that is unique for where the dust will be. So perhaps you don't get so much information from the vertex paint that you will have a dust here on that part. It will more be on the edges, but if you have an object that is standing for a while, you know that this part will have a lot of dust. So by using the normal, then we can see where all those tiny dust particles will be, and then we can subtract a bit from the vertex paint to make it more believable in some areas, because we will get dust in places where this normal doesn't reach as well, and then we can put in the vertex paint there as well. So we can use those two in combination to find the perfect spot for where we have all the dust. So now you know that as well. So using the normal with the Z output, and we can of course control it here as well. I can put it in just so you see it, converter and the color ramp, to decrease or increase it. In most cases it will not be so that you want to have it really hard, but in some cases it could be that you only want to catch what is completely on top. But in most cases you would like to have a rather soft area where you can work from. But you have the possibility to filter that as well. So as I said, what you have seen in this session is using the pointiness with this calculation here to find out where we touches the material or the object, or using the normal output with the separate XYZ and use the Z to find out where the dust will arrive when we don't use the object. So 2 more tools and then we almost have everything. I will go through just a few more, and after that we will try to work with this in practice as well. Okay, so see you in next session.